All right, guys, let's go ahead and continue. So moving on with more identity access management. We already talked about single sign-on. So that is using a centralized identity provider to give a seamless sign-on experience, right? Hitting sign in with Google, hitting sign in with Microsoft, and doing sending that access request to those identity providers. Active Directory. That's another huge directory service that we're going to talk about. That mainly is on-prem. That is something in Microsoft enterprise environments that we're used to managing with domain controllers. Active Directory talks different protocols than cloud-based protocols. So remember, cloud-based IAM, identity providers, Entra ID, Google Cloud, AWS, IAM, they speak internet protocols, HTTPS, SAML, OAuth 2.0, where Active Directory, that's actually going to speak Kerberos, NTLM, and LDAP, the Lightweight Directory Access Protocol, which allows you to query an Active Directory database. SAML, it's another markup language. I think it stands for Secure Assertion Markup Language. SAML is another protocol that allows us to have an SSO experience. You see this in a lot of education, but using SAML. Okay, so recognize identity and access management services. So again, different directory services. We already talked about Active Directory. That's what we have up on the screen here. LDAP, the Lightweight Directory Access Protocol. So LDAP is used in Active Directory. It's hierarchical in nature, and it can be used to query databases, specifically Active Directory. Now let's go over physical and logical access controls. So different ways we can have our access control and our governance. And what we mean by that is when we look at our architecture, look at our enterprise, what kind of access controls do we want to have in place to protect our identity and to enforce good security controls? So we have these different access controls we're going to go over. So MAC, that stands for Mandatory Access Control. That is on a need-to-know basis. So this is what the government does. If we're on a secret network, Mandatory Access Control states, hey, you need to have the clearance, we need to do a background check before we give you access to this entire network here. In the private sector, they may have something similar, where we have a research and development department that says, hey, this is our R&D network, air-gapped or completely segmented from the regular enterprise, and you need to be on a need-to-know basis to come in here to see the IP that we're working on. That's the intellectual property. So that is mandatory access control. It's on a need-to-know basis. Discretionary access control, that's DAC. That's going to be the default access control in Windows machines, where if you create a new folder, so you're the owner of that folder, you're going to determine the read, write, execute, the full permissions of that object. So that's what we have in the image there. So it looks like whoever created this folder, right, or this file, because that's index.html, that file there, they have control over who has access to that file. We call it discretionary access control, where whoever created it determines the permissions on it. Then we have role-based access control, RBAC. What you're going to see in all your cloud environments is, yes, we create a user. So like in Microsoft Entra ID, we create a user. But what's their role? Are they just for storage? Are they a compute administrator? Are they a network administrator? And whatever their role is, we're going to follow that principle of least privilege to assign them access, to assign them permissions. Rule-based access control, this is like giving login hours. This is saying, hey, you can only on-prem environment sign in to this computer. That's rule-based access control. And if you're familiar with Active Directory, you've seen this when creating a user. You can set logon hours, right? Okay, some other things we need to be aware of is our account lifecycle management. Essentially what we're saying there is we don't want that privilege creep, and when we offboard, we need to actually delete accounts or disable accounts. So we need to make sure that we have good lifecycle management with our accounts. If we hired and fired somebody, we need to make sure during the offboarding procedures that their account's getting disabled or deleted. Federation. So federation is when we combine enterprises, where we give federated access to two businesses, two organizations that are going to work together. Now we talk PKI, the public key infrastructure. we can utilize a public key infrastructure to give us X.509 certificates that can be used for our users. So we're not going to dive too deep into PKI, right? But PKI uses asymmetric and symmetric cryptography, certificate authorities to assign X.509 certificates to websites that enables our TLS sessions. But within an organization, we can also we can set up a PKI server, certificate authority, to actually issue out certificates to users. And we can assign those certificates to a user's account, put that on something like a common access card, and say, hey, when you sign in, we're going to use that certificate. Key management or secrets management. So in the cloud, we can have secrets management, or maybe we're doing something like infrastructure as code and we have a key vault that we're using. All right, awesome. So that is going to be domain 2.1. We don't have a quiz for this domain, guys, for these lessons, so we're just going to move on to domain 2.2. Okay, so now let's move on to domain 2.2. This is going to be secure a network in a cloud environment. So what we're going to talk about here is, even though we're in the cloud and it's software-defined networking in the cloud, what tools do we have to secure our cloud? And again, a lot of the things that we did on-prem correlate or translate to the cloud. Not maybe on a one-to-one basis of technologies, but how we segmented, how we did logical segmentation, how we configured security with firewalls. No, we may not have a physical firewall appliance that we have in the cloud that we configure. Like, we're not going to configure a Palo Alto firewall and go put it in a cloud data center for our stuff, right? But a lot of that rule set, those ACLs, the permit and deny statements, we can still do in the cloud. So we're going to go through that during this section. But first, let's go over understand network flow diagrams. So network diagrams. We need them for on-prem. We also need them for the cloud. Diagrams don't go away just because we're working in the cloud. They actually become a little bit more complex because of all the resources that can be in your little cloud environment, right? That can be deployed and how they get segmented. So it's important that we create good network diagrams, one, for our security. So we understand the data flow and where maybe in that chain could be a weak link, right? At least when it comes to the network. It helps us troubleshoot. So and this is an on-prem diagram, but if this dev app server can reach here, but can't go out to the workstation, but this HR can go all the way through, well, if we know it's getting stopped at the firewall, this network flow diagram helps us, keen in on that. Because we could do like a trace route from here and see that our ping gets stopped right there. And then if we have a good network diagram that has the IP addressing for this link, let's say it's like 10.1.1.2, we can say, oh, it's getting stopped at 10.1.1.2. That's my inside interface on the firewall. So let's go start troubleshooting at the firewall. Network diagrams help us with migrations to understand our inventory, right? Understand our assets in the business. And if we want to migrate from like on-prem to the cloud, well, what was protecting our on-prem servers, and can we still have that level of security in the cloud? Okay, network segmentation. So again, here we see an on-prem solution using VLANs to do layer 2 network segmentation by inserting a 4-byte header into that Ethernet frame using 802.1q encapsulation standards. And that's going to give us logical segmentation on our switched environments. In the cloud, however, though, we don't have VLANs. We're going to use something called VNets and subnets, or VPCs. We'll get to that, though. Okay, so more security and segmentation. So again, this is more of a data center technology, but the CompTIA Cloud Plus wants us to talk about it. VXLAN, okay? VXLAN is going to enable us to extend our layer 2 environments. So it's pretty cool. This is called data center interconnect. So essentially, we can have geographically dispersed data centers that have the same, so we'll put a router here. We'll put a switch here, and this will be our VTEP, our virtual tunnel endpoint. And then again, this is going to relate to VXLAN, virtual tunnel endpoint. And we can have our data center here that is VLAN 10. That's 10.10.10.0/27. And guess what? In our geographically dispersed region here, because of the VXLAN tunnel between our virtual tunnel endpoints that gets tunneled through this layer 3 backbone, we can have the exact same layer 2 in this data center, in this data center. So these servers that are thousands of miles away, through the use of VXLAN, which allows us to tunnel our original layer 2 Ethernet frame through a UDP VXLAN header and then layer 3 and so on, right? To believe they're part of the same exact broadcast domain. So we have a data center interconnect. And this enables us to do a lot of cool things. So we could have ESXi hosts here, cluster those ESXi hosts, and do vMotion to actually migrate VMs between these data centers that are 1,000 miles away. That's VXLAN. Genevieve does the same thing. I've never configured it. I've never used it. So I know it does the same thing as VXLAN, but I can't dive too deep into it. But then we have microsegmentation. This is going to be more cloud specific. Microsegmentation. So microsegmentation is when we filter east to west, and this is where we put network control on the actual at the resource level. So an example of this in the cloud. So again, I'm going to use an Azure example here. So in Azure, when we want to segment by networks, we create what's called VNets. Okay? These VNets are tied to a region. So if I create a VNet in the west region and I have a resource in the east region, I cannot put that resource as a part of this virtual network. Okay? So if this VNet is in the west region, all the resources I build, regardless of what subscription they're a part of, if I want that resource, a virtual machine, storage account, containers, databases, whatever the case may be, to be part of this VNet, they all have to be within the same region. Okay, so that is one of the standards with these VNets. It's region dependent. So when I have a VNet, okay, so let's say this is VNet 1. This is 10.0.0.0/16. What I'm going to do, and again, I'm going to put this, and this is going to be in the US West region. I can create subnets. Okay? I can create subnets within this virtual network. Okay, my pen just wants to freak out. One second here. Actually, what we're going to do here, guys, sorry, I'm going to take like a little pause here. I'm just going to I am going to just bring up my Zoom whiteboard. Let me bring up the Zoom whiteboard. Okay, here we go. So back to how we segment and do micro segmentation, because that was the what I was teaching. Okay. Okay, so here's how we do micro segmentation. And again, I'm going to use an example using Azure resources in like a vocabulary, because that's what I know the best. But in Azure, and this is going to be the same concept is going to be in Google Cloud and AWS, just going to be called different things, okay? We have VNets, virtual networks. So we have VNet 1 here. And that'll be 10.0.0.0/16. And in that VNet, we have different subnets. So let's say this is subnet 1, this is subnet 2. And that subnet will be like 10.0.0.1.0/24. And this subnet will be 10.0.2.0/24. And in this subnet, we can place our resources. So we can create VMs, and we can say, hey, all the VMs are going to go in subnet 1. And then we can create containers. I'm just going to put CT for containers there. We have container instances. We're going to put all of our containers in subnet 2. Now, if these two resources ever need to talk to each other, we can set up micro segmentation between resource to resource using these subnets. So at the subnet level, we can put ACLs, what's actually called NSGs, network security groups in Azure. But we can put these network security groups that will allow us to have what we would be used to like an on-prem access control entries, which would be like permit and deny statements. And that's microsegmentation. So segmenting resources within a virtual net using these subnets. And that's going to be an example of microsegmentation in the cloud. AWS, they call this VPCs, virtual private clouds. In Google Cloud, I think we just call it like something network, just like something network. I can actually bring it up once I share my screen again, but something network, okay? But we call this east to west filtering as well. So you notice, right, how I drew it up here. We filter east to west. Where in a traditional network environment, something like this, where we had PC1 here, PC2, PC1, and let's say this was part of VLAN 20, and this was a part of VLAN 30. They traveled north to south here, right? Because if PC2 want to talk to PC1, the way we were segmented was via layer 2, but to talk to each other, we needed a layer 3 device. So PC2 would have to come up here and back down. So that was kind of north to south, right? Where this is east to west. Okay, let me share my screen again. All right, so now let's go over some network services that we may want to protect. So we have DNS. That is an inherently insecure network service or application that is necessary for the internet to work, right? It does our our name resolution. It resolves a domain name to an IP address. An IP address is what the computer needs to talk, to send that HTTP request. As humans, we memorize URL names, domain names, right? So DNS inherently insecure. We have these protections. We can do DNS over HTTPS, which is, secure because HTTPS does TLS. So when you make an HTTPS connection, you do your TCP three-way handshake, you do your TLS connection, and then you do the hypertext transfer protocol connection. So if we tunnel DNS through that, so we send our DNS request via an HTTPS request, our DNS server's accepting that, port 443, right? We're protected. We can do DNS over TLS. So just straight up tunneling a DNS over a TLS connection. So doing our DNS request through a TLS tunnel rather than tunneling it through hypertext transfer protocol. So that's going to give us data in transit confidentiality. It's going to do encryption for us. DNSSEC. So that is just a security extension that gives us non-repudiation and authentication when we do our DNS request by leveraging a public key infrastructure. So it uses like digital certificates to say, hey, I'm only connecting to this root DNS server if I can verify that it actually is my DNS server, not someone doing a man-in-the-middle attack. Okay, so we have different firewalls. So regular firewalls on-prem that are hardware appliance are stateful or stateless. We have web application firewalls, WAFs. That's going to be for our web applications, right? Our web servers, and it's going to be monitoring HTTP connections, okay? It's going to be monitoring HTTP connections and seeing if there's anything malicious during that HTTP connection. Other resources or other technologies we can employ on the network to protect us. Oh, sorry about that. IDS and IPS systems. So intrusion detection systems are going to be monitoring and alerting us when there could be something malicious coming across the network. IPS is going to be doing prevention. So we can integrate IPS into like our SIEM solution, our security information event management solution, and actually prevent anything malicious from coming across the network. Data loss prevention. That's when we classify data on our network that we don't want to get exfiltrated. So we can put DLP on our users' workstations. We can do it inline. We can integrate DLP again into like our next generation firewalls that's looking to stop PII from getting exfiltrated. We have network access controls. So network access control is going to utilize AAA and 802.1x to give us authentication and authorization for network devices trying to get on the network. This protects us, like let's say we have a lobby and we have network jacks there, import ports. Someone wants to plug in a Raspberry Pi with Kali Linux to do something malicious on our network. If we have network access control, it'll stop that, right? Because we may have to have some sort of certificate on a computer to be part of the right VLAN. Maybe we have MAC authorization bypass configured. Okay, secure time management. So timing is very important in our environments. Look about Active Directory when we have our Kerberos authentication protocol so that servers can authenticate in our Active Directory domain. We need accurate timing. There's a lot of other reasons we need accurate timing. Maybe on our WAN ports, we have WAN keys between our OSPF neighbors, and we need accurate timing. So we have two protocols we can use. The network time protocol, which is inherently insecure. It runs over UDP port 123. Then we have the network time security, which is just another timing protocol that's now secure. Has security overlaid on top of it. Okay, another thing we can do is harden. We always want to harden wherever we can. So let's say we're doing infrastructure as service in the cloud. We deploy a VM. And now that VM, we need to make sure is secure. We don't want to leave open ports. I showed you that example yesterday of a VM being left online with Telnet, it getting exploited and used as a torrenting hop. Well, if we would have done proper hardening on that device, that wouldn't have happened. So we want to disable unnecessary ports and services anytime that it's necessary. And pretty much it's necessary anytime you have a device that has those inherently insecure ports. If it has additional services on that you don't need on to accomplish its job. So what we can do to harden: disable weak protocols and ciphers. We don't want any legacy protocols and ciphers being online. So we don't want like SSL 3.0 to be able to be used or TLS 1.1. Make sure we're doing firmware upgrades. So don't always think about just the data in the wire in transit. Think about our hardware, right? Does our hardware have the right firmware? Are we doing proper firmware upgrades? Controlling our ingress and egress traffic. So let's say, in the cloud, it's software-defined networking. Do we have like a gateway, a load balancer, internal and outside load balancers that are controlling our ingress and egress traffic? Are we protected against DDoS attacks? Do we have some rate limiting on our APIs? Do we have proper, again, load balancing? Are we protected against things like SYN flood attacks? Okay, awesome. So that is domain 2.2. Let's go ahead and take another. Let's come back at 10:30. My voice kind of hurts. I gotta chug this 5-hour energy too, so I get more motivated. Yeah, let's come back at 10:30, guys, and then we'll go over domain 2.3. Whew, 10-minute break. Let's go. These live virtual trainings get rough. All right, be back in 10. I'm going to put a little clock up there, though. All right, let's go back to it, guys. So now we're going to go over domain 2.3, manage cloud operating system and application security. So kind of within this security section, we talked about the network, we talked about identity, and now we're going to talk about our operating systems because, like I said, remember, infrastructure as a service, you're going to deploy a VM, and that OS is going to be your responsibility to manage the patching, the updates, the hardening, everything about that VM. Okay, obviously, the back plane, the things you don't see, managing the control plane, the console, the portal, that's on the cloud service provider. Everything else is up to you. Then we got to go over application security. We deploy apps in the cloud. It's kind of like, not to say the whole point of the cloud, but one of the big features of the cloud. Because at first it was like storage that was used a lot in the cloud, like S3, AWS S3 buckets, EC2, like the first big cloud offerings that kind of took off. But application security. So let's say we have container apps. How do we secure them? Let's just say we deploy a web application. How do we secure our web applications in the cloud? And again, a lot of the stuff we did on-prem translates. The only thing that may differ is in the cloud, maybe how we deploy it. Maybe the architecture is a little different. Maybe the tools, the monitoring tools that the cloud provider gives us are a little different. Okay, so hardening and mandatory access control. So operating system security. We want to have hardened baselines. And what we mean by that is, let's say we have, this is an on-prem thing too. Let's say we have an operating system that we constantly use. Let's say it's Red Hat Linux server. And we're constantly deploying that in our cloud environments. Well, we want to have a baseline for that image that says, hey, these things will be turned on or turned off for this operating system. We want to have that hardened baseline. We want to have that as an SOP and also within the image itself. If we can create that hardened image, then that's going to correlate to our hardened baseline that we may have within our organization. Configuration management. So again, I think of this as kind of the technical, logical, and from the management perspective. We want to have good configuration management just within our enterprise as a whole. Now, when it comes to the cloud, there's a lot of different ways we can do config management. If we're in a multi-cloud environment, which is kind of, we're CompTIA Cloud Plus, we like to do that. We like to talk multi-cloud environments. Maybe we use things like Terraform or Ansible to do config management. And again, maybe we have playbooks or runbooks that determine what kind of configuration management we're going to have within the organization. What kind of build types do we have? So are we deploying OSs that are stable? Are we doing research and development? We have some beta OSs that we put in our cloud environments, okay? What kind of support do we want? If we're going in open source environment, we got to understand that if we're deploying a Linux VM in production to run an essential service, maybe for a customer, for ourselves, we don't have long-term support. Unless it's obviously Red Hat Linux, which is kind of open, closed source, it's in that little gray area. We don't have that long-term support. So that's something we have to think about as well, kind of our lifecycle management with our VMs and the operating systems we deploy in the cloud. We want to make sure that we don't have a deprecated OS. And if we do, hopefully there's a good reason. And what I mean by that is sometimes you deploy an OS, there's an essential feature, app, or service running on it, and now it's hard to migrate off. For whatever the reason may be, we just haven't found a good path forward to migrate off that. So instead, we put in compensating controls. We put that OS in its own subnet, in its own VNet with good network security groups. We put that behind a load balancer and a NAT gateway, right? So if we do have that deprecated OS, we want to have some compensating controls. Now in the cloud, how do we manage OS upgrades? So obviously in a in a Microsoft environment, they have a lot of tools. We can do SCCM to manage our Microsoft upgrades. We can deploy a SIEM to monitor our upgrades. I've used Splunk in the past to monitor our Windows versions. So we had like 21 Hotel 2 moving to 22 Hotel 2. I can't remember the actual versions. And in red was the old, and green was the new. So we could see what we had to upgrade. And in Azure and AWS and Google Cloud, we have similar monitoring tools. We need a hardening checklist. So besides just having a baseline, maybe we make that part of our playbook, our SOP, that when we deploy an OS as a cloud engineer, we have something in our knowledge management base that says, okay, you deployed a VM, here's the last step, go through and do this hardening checklist. And that could look like just, hey, make sure these things are clicked in the cloud console, okay? Or maybe if we're doing infrastructure as code, we're saying, okay, you know, in this Terraform script, in this Ansible script, make sure you do this. Okay, then we want to also configure software security. So on our operating systems, even in the cloud, yes, if you have a Windows server running in the cloud, that's still just Windows Server, we can download AV and AM. We can download antivirus, anti-malware solutions, okay? If we downloaded CrowdStrike, you know, that would have been kind of messy a month ago. But anyways, antivirus, anti-malware is something that we want in our operating systems. Endpoint detection and response, so EDR or even XDR, something that I don't believe it's in this Cloud Plus objectives, but the new exam's coming out soon, and it will be EDR and XDR. They do the same thing, so endpoint detection and response. It'll alert us if there's something malicious, and then we can also, as an admin, go and configure our EDR systems to respond to that malicious thing that we may have detected, i.e., put that malware in a sandbox, maybe detonate it, maybe just delete it, whatever our response may be. Extended detection and response, that's where we kind of have a cloud-based centralized service for our detection and response instead of the EDR living solely on just the individual OS, okay? So it does the same thing, but extended detection response just has a different architecture. Okay, we just talked about this. Intrusion protection systems. So that's detection, prevention, protection, right? Software firewall. So think about this like Microsoft Defender. That's a firewall that lives in software. If you think about how the cloud is software-defined networking, you can consider the firewalls that you deploy in the cloud, like firewalls as a service, also technically a software firewall. Log and event monitoring. So like Azure has something called Azure Sentinel that's going to allow us to do log and event monitoring. We can also integrate a third-party log and event monitoring. So we can integrate a SIEM solution, SIEM/even SOAR solution like Splunk, right? Okay, then file integrity. Maybe we want to deploy something like FIM, file integrity management, to say, hey, if a file has changed that wasn't supposed to change, we want to get alerted of it as an admin. And maybe we're a cloud engineer that sits at the NOC, or maybe sits at the SOC and works together in a nice collaborative team. Maybe we have the SOC alert us of that, or maybe we're part of that alerting when it comes to our cloud environments and files. Okay, then user security. User security, we want to have good password policies. So whether we're in Microsoft Entra ID or Active Directory, we want to have solid password policies if we have passwords. Now, depending who you ask, sometimes passwordless authentication may be recommended. We want to have good application allow listing. So this is like whitelisting versus blacklisting. And this comes down to your environment and how granular of control you want. So with the allow listing, this is saying, hey, these applications can or cannot be installed by the user, and then everything else is denied. So pretty much with an allow list, you have that implicit deny at the end. And then if you want applications to be able to be installed by users, maybe you have some sort of centralized software center that's unique. Maybe you're not just letting them download straight from the internet. You have some sort of app store in your enterprise. Then you got to go through and allow individually those apps, right? Office 365. Allow whatever desktop applications. Now this is versus blacklisting, where blacklisting has an implicit allow. So you're allowed to download anything. And so you may ask, well, how is this secure at all? Well, now that's up to you as an admin, and whether or not, again, you're that security administrator, that cyber, that SOC analyst, system administrator, the cloud engineer that's doing this, maybe in a cloud environment, you got to go and hit deny. You have to deny specific things and everything else will be allowed. Okay? And then, of course, we want to have good user and group management and good user permissions. We kind of talked about that in our IAM section, where we do role-based access control and we do policy-based control. Okay, now encryption. So where do we want to apply encryption when it comes to our operating systems? So operating system application security. So when we have an application in our cloud environment, maybe that's an API endpoint. Maybe we want to apply some rate limiting and apply encryption there. So that would be like data in transit encryption. Maybe we say, hey, when you hit this API, we want to put TLS over that, okay? Maybe our application, same thing. Maybe our application's web-based. What do we always want to do? HTTPS, right? Always have it secure. Operating system encryption. This could be something like full disk encryption. So this is kind of our data at rest, right? How do we secure our data at rest? Well, apply full disk encryption. This could be something like BitLocker in Windows. Off the top of my head, I don't know like what Linux could possibly have, but in the cloud environment, sometimes this comes standard, right? This can be just an additional feature you can put when creating that VM. Storage encryption. So this is also going to be data at rest. And this could also be like an FDE solution, full disk encryption solution. So when we're building like a storage account in Azure, we can choose what kind of encryption we want. We can have like Microsoft managed keys or custom keys. So let me delete this. Let me show you that, okay? So if we come here to Microsoft Azure, we come here to a storage account. Let's go ahead and create a new storage account. Subscription, fine, resource group. Let's just say test storage group. Remember, this storage account name has to be globally unique. So literally, like within all the storage accounts ever used in the Azure public cloud, this has to be unique because it has a unique DNS name. Do Tripletext storage 01234. Okay, that's really not the point I'm trying to get at. We can come here to encryption. So you can see that we can do encryption on this storage, and we can have Microsoft create a key for us for that encryption. We can do customer managed keys. I just noticed it's a little bit off the screen here. There we go. We can do, and then we can say, hey, is this going to be for all of our storage or just for our blobs, files, and tables? But either way, you can see it's kind of built into the cloud. Now, if you have a storage area network using NetApp, using Dell EMC, this may be something that you have to go configure. They may have a GUI as well, right? That allows you to do that. But we can also enable infrastructure encryption. Okay? So we have encryption for our storage kind of automatically in the cloud. Okay, then file systems. So what we're saying here is that our file systems also need to be encrypted. That's going to be data at rest as well. Where we apply encryption on a per file basis. So TPM. So before we talk about virtual TPM, let's just talk about what a TPM is. So TPMs enable UEFI, which is secure boot, right? So what this does is these TPM chips will sit on our motherboards, okay? Secure boot. These TPM chips sit on our motherboards. And when all the hardware and the firmware is OEM, upon first boot, we're going to get a hash when we do our like BIOS check, essentially. We're going to put that hash in these TPM chips. And now every time we boot our system, whether it's a server, whether it's a desktop, your regular computer at home, we're going to get a hash of that firmware and that hardware and compare it to that original hash we have in our TPM. And if it's the same, that means there was no, like, has been exploited, there's no change, we have integrity, we're going to boot as normal. Now we're going to boot into our OS. That's what these TPM chips do, okay? By, like, the default, the fundamentals, right? So in the cloud, when we're deploying VMs, we can enable virtual TPMs. And like in Azure, this like second gen VMs will have secure boot. And we'll have these virtual trusted platform modules, remember, in our control plane, you know? Well, boot, it's kind of like more data plane, but I guess what I'm saying is that's not something you have to worry about. It's just a little click, a little feature that you enable. And in the cloud data centers, they'll perform the same secure boot that you would get on your desktop environment local. All right, let's move on now. Okay, so that is domain 2.3. Now let's move on to domain 2.4, and then we'll go to about 11 o'clock, and then we'll break for lunch. Okay, guys? Let me bring up domain 2.4. All right, so this is going to be managed data security and compliance in the cloud. So whether or not we're talking really cybersecurity in general, whether protecting on-prem, whether protecting our remote workers, protecting our cloud environments, data security doesn't change. We have the same goals. We want an onion-layered defense in-depth approach to protect our assets. We want to make sure we have confidentiality, integrity, but also not kill the availability for our users, customers, and whoever else is on our enterprise. So data security doesn't change. Now, how we apply it, how we do security in the cloud differs a little bit on-prem when it comes to the actual technical application. Compliance in the cloud. Data compliance and data sovereignty also doesn't change. If I work in healthcare, whether or not my servers are on-prem or in the cloud, I have to abide by HIPAA regulations. If I'm an e-commerce data processor, so I'm processing credit card transactions, well, guess what? PCI applies whether or not my servers are on-prem or they're in the cloud. So our compliance, the laws, the regulations don't change. There's going to be additional things involved with the cloud. Like, for example, if we want to sell a SaaS application to the government, we have to be FedRAMP approved. So to get cloud-based applications into the DoD environment, they have to be FedRAMP approved. And that's a whole process. So compliance and the cloud may differ a little bit. There may be things you have to worry about that are a little different, but the regulations have always been there, apply when you put resources in the cloud, okay? So let's go ahead. So first we're going to talk about data loss prevention. DLP, our DLP software, our DLP solutions. What's the goal? So overall, it's stop data exfiltration. How do we do that? We can apply DLP at the actual operating systems, the host systems. We can deploy it in line at our next generation firewalls, okay? To do DLP correctly, first we have to identify and classify data that we don't want to be exfiltrated. This can be very easy depending on your industry. Like I already said, if you're working with PCI, HIPAA, or you want to make sure PII doesn't get exfiltrated, well, PII, maybe it's easy as saying, hey, if you see something like this coming across the network, 0 through 9, stop it. Stop it from leaving our gateway, because that's PII potentially, okay? So we classify, tell the DLP to protect, and then consistently always monitor the network or monitor that endpoint to make sure that we always have the opportunity to stop data from being exfiltrated. Manage encryption. So when we are deploying encryption to our data at rest, our data in transit, or even our data in use, that is something that we can potentially do, encryption is going to give us confidentiality, okay? So that's number one. Encryption will give us confidentiality. It turns our plain text into ciphertext. Now, integrity. To verify integrity, we typically use hashing, right? Or digital signatures, which I'm going to get to. So, confidentiality, that's our encryption. That's using symmetric or asymmetric encryption for our data in transit or our data at rest. Okay? Integrity. We can use hashing to verify integrity. We take a hash of a file, we can check the next day, take a hash again. If it's changed, that means the file has changed, okay? Non-repudiation. This is kind of like verification, where if I'm the sender and I attach a digital signature on there, and I'm able to decode that digital signature and our PKI environment, right, public key infrastructure, that lets me verify that the sender actually sent me this and it's not spam, okay? So non-repudiation, we use things like digital signatures, okay? The combination of these two is what delivers us non-repudiation, because a digital signature uses asymmetric encryption and also uses hashing to be created, okay? And the way that works is essentially, again, this is not a Security Plus class. I won't go too deep into it. But essentially, the sender takes its private key, takes a hash of the message, takes its private key, encrypts that message, okay? Encrypts the hash of that message. And then the receiver takes the sender's public key, decrypts that hash, rehashes the message, compares the two hashes. If they're the same, then we verify that the sender is actually who sent it, okay? But don't worry, don't get too wrapped around that. This is not a Security Plus class, okay? So manage data integrity. We have different hash algorithms, different signatures, file integrity monitoring. So the different hashing algorithms we have, like SHA, MD5. So SHA-256, SHA-512 is going to be our most secure hashes. And then let's talk about data classification. So data classification in the private sector. These are just some of the ways we can identify and classify traffic. We can classify it as non-business, public, general, confidential, or highly confidential. As we know in the government, we have different ways to classify. It's like unclass, confidential, secret, and top secret. We can configure segmentation to secure our data. We can have different subnets. Like I already talked about in Azure, we can have different... I was going to bring up the whiteboard, but I have to stop sharing my screen. That's okay. We can have different subnets that let us segment our cloud environment. Okay? So as you see here, our Azure cloud, we have these different VNets that are connected here. Okay? So we can have virtual networks configured as peers. So we can have that segmentation, but we can also configure peering between those VNets that allow us a direct connection. Kind of like our IPsec tunnels used to do, but now in the cloud, we can peer VNets, okay? And this is going to be an Azure solution, okay? We can even have a hub and spoke topology where we have a hub VNet and those two are peered. And then we have different subnets that are hanging off that VNet. Access control. So this shows you a good example of Azure, which I've already shown you on the screen. But remember, when we administer access control in Azure, it starts at a management group, then a subscription, then a resource group, and then a resource. So I come to my portal here. Let's make sure I'm in my right tenant here. Hold on real quick. Okay. So we have management groups here. So we have this tenant root group, and you see underneath that, what do we have? A subscription. So when we're applying role-based access control, Azure policy, and budget, it starts with the root group, and we place a subscription underneath there. Or we can have other management groups underneath that also have, you guessed it, a subscription. Or these management groups could have another nested management group underneath that. So that's kind of how Azure works, right? If we're doing a basic architecture, though, we could just have this root group, a subscription underneath that, and we can apply access control at the subscription, and then all the resource groups in that subscription will get that same, inherit that same access control. So then if I come here to resource groups, and when I want to create a resource group, guess what I have to place it under? A subscription, guys. Give it a name, my resource group, Cloud Plus. Put it in a region, yeah, and then we can go and create it. And then when I create a resource, right, so, well, the resource group, we can also put access control, okay? We're going to inherit what we got from the subscription, but we can also put more access control here, maybe something more granular. And then if I want to go create a resource, so I want to go create storage account, I can put that under the new resource group I just made, okay? And that's kind of how we do our access control in Azure. And again, in Google Cloud, it goes organization, folders, and project, and then resources. Sorry, I don't know how AWS is laid out. I only really know Azure and Google Cloud well when it comes to access control and hierarchy and things like that, okay? All right. Understanding the impacts of laws and regulations. This will be the last thing we go over, and then we'll break for lunch, guys. We'll probably have like an hour and a half break. I need to rest my voice again, drink some more caffeine. Understand the impact of laws and regulations. So all this is saying is you have to understand the different data sovereignty laws. How your intellectual property is protected in different areas. What liability. So you need to do your due diligence even when you're working in the cloud, okay? You have to understand the different legal holds and different legal proceedings around the world. Like think about Twitter, right? If you ever work for a huge company and you're an engineer and you're working in a different region, I don't know the story, but I think they got kicked out of Brazil or something. I don't know. But that's something that Twitter probably got like oh my God, like we didn't think this was going to happen, and now we have to work around the legal boundaries of that country we're operating in. This happens all the time in Europe because Europe has the GDPR, the General Data Protection Rights. And again, I'm not political at all. I don't know what the hell. I don't know what happened in Brazil. I just heard on the news somewhere that Twitter got like kicked out of Brazil or something. But in Europe, this happens all the time. You see sometimes, depending who you ask, innovation coming out of it, or maybe holding a company back, like with the iPhone. The GDPR, the European Union said, hey, every phone's gonna have the same charger. So then the new iPhone has to be USB-C. So now our new iPhones in America are USB-C as well because Apple's probably like, we don't want to manufacture two different iPhones, right? For two big markets. So we have to understand the laws and regulations of which we're operating in. And with the GDPR, it's always a big one because this plays into your sales team, your marketing team, your tech team, your IT team, the dev team. When we have to worry about those users' rights and data protection rights, we can't let certain data leak. We can't sell people's data, European customers' data, or we may get fined. Like, I think these big social media companies get fined just about, it feels like every year. It almost feels like they're just doing it as like hey, it's just the cost of doing business, right? But we have to understand that, okay? All right, just trying to see how much is left. Okay, we'll go to lunch right now because it's 11. I'm hungry and I gotta drink this caffeine, rest my voice. So when we come back, we'll finish domain 2.4. Let me check what we have for the rest of the day, guys. I think we just have 2.5 and 2.6. Yeah, after lunch, we'll come back at 12:30. We just have domain 2.5 and 2.6. Finish up domain 2.4, and then we'll be done for the day. And you guys will be released to go do questions, okay? You got to make sure you're doing your questions, though. All right, guys. So I will see you at 12:30. I'll probably leave the Zoom open. I'll leave the Zoom call open. All right. Everyone have a good lunch.